Good morning. This is Mr. Precella, and today we're going to be looking at some applications involving linear functions. By now you should know that applications in math always mean word problems. So this is going to use stuff that we've already discussed: midpoint formula, the slope of a line, how to write the equation of a line given a point and the slope. So to get started, let's see. Here's our first problem we're going to do today. It says the graph depicts the growth in cost using a line segment. Use the midpoint formula to approximate the cost during the year 1987. So let's see, what is this little chart here, this graph? It says it's the average annual cost of tuition and fees at a 4-year private college from 1983 through 1991. So it looks like in 1983, the tuition was $5,041, and in 1991, the tuition was $9,973. We want to find the midpoint. Let's see, if we go like this, where would be right in the middle, right there. So it's right out in there. And we're told that the midpoint should be at the year 1987. So let's see, 83, 84, 85, 86. Yeah, I think that is 1987, right there in the middle. Now, what is this midpoint formula? Do you remember how to calculate that? You average the x's and then average the y's. By average, I mean you add them up, divide by 2. So let's just verify that 1987 is the year right between 1983 and 1991. If I add 1983 plus 1991 and divide by 2. Ooh, the screen just got dark for a moment. That's just this motion sensor here. Let's see, some of you with the calculator. 1983 plus 1991, add those up and divide by 2. Did we get 1987? Yes? Y'all not talking today? We'd have 3974 dividing by 2. We are getting 1987. So all that does is verify, yes, the midpoint formula will get us this y value here. The year right between 1983 and 1991 is 1987. So now let's do the same thing with the y values. Add them up and divide by 2. 5,041 plus 9,973. I'm just going to punch that into my calculator. 5,041 plus 9,973. That's 15,014. Dividing that by 2, 7,507. So, how did finding the midpoint help us answer this question? Well, the approximate cost during the year 1987 is $7,507. Okay. Any questions there? Let's see, I think the next problem is something similar. Let's see, it says, the table lists how poverty level income cutoffs in dollars for a family of 4 have changed over time. In the year 1970, income of $36.83, that would have been the poverty level, while for a family of 4. While in 2004, it was up to $19,436. Anyone making below that in a family of 4 they are definitely living in poverty. So let's see, use the midpoint formula to approximate the poverty level in 1987 to the nearest dollar. Well, this one doesn't have a nice graph like that. So let's verify that the midpoint formula will actually work for this. Let's make sure that 1987 is the year right between 1970 and 2004. If I add those years together and divide by 2, in other words, if I average them, do I get 1987? If I don't, then the midpoint formula really wouldn't be applicable here. So let's see, 1970 plus 2004, dividing that by 2 is 1987. So yes, we can figure out, or we can approximate the poverty cutoff in 1987 by using that midpoint formula. So these are the X's, just like over here. The years were X's, the dollars were the Y's. In economics, you will almost always find when you're looking at graphs that time will be horizontal or quantity, but dollars are usually on the y-axis in any sort of economics. Right? So let's add the two y's together, 3683 and 19,436, and divide by 2. And you might be thinking to yourself, well, what about these other numbers here? Why aren't we using those? Well, for the same reason here on this one, we only looked at the beginning and the end there. We didn't look at these points here when calculating the midpoint. So let me see, where's my calculator? I'm using my calculator on my phone just because that shows better. Probably in your class, if you're taking a test, your teacher's going to not let you be punching on your phone during the test. But I'm just using this calculator for the video purpose because it shows up better than my TI graphing calculator. 3,683 plus 19,436, then divide by 2, and we get 11,559 and 50 cents. So approximately in the year 1987, the poverty level cutoff was $11,559.50. Wait a minute, if I punch this into my math lab, I'm going to get wrong. Why? It says round to the nearest dollar. I should have noticed that all of these are in terms of dollars here. So your answer should sensibly be rounded to dollars. So I'm not going to put in $11,559.50. I would round that to $11,560. 50 cents gets rounded up. If it had been 49 cents or less, I would have just dropped the cents and left it at 59. So there, $11,560. Now, any questions here? We're just looking at some nice little applications involving linear functions. I'm going to do 3 right today. And we'll do some more in another video, or in the next video, the next class. Let's see. Problem number 3. Let's see. What is this? I don't think this is a midpoint problem. Let me read it. The table gives the number of cellular telephone subscribers in a country in thousands from 2002 through 2007. Find the average annual rate of change during this time. Or the average annual rate of change. What do we mean by that? Well, when we're looking at lines, the rate of change is what we call the slope. Do you remember, how do you calculate the slope? Well, it's rise over run. To get rise, you can go y2 minus y1. Second y minus first y over second x minus first x. So if we want to if we want to calculate the slope, do y'all see the two ordered pairs we're going to be using? The first and the last. My first ordered pair would look like this: 2002, comma 273,229. The second ordered pair, 2007, comma 322,940. Ooh, having that comma there is sort of problematic. There. This is x1, y1. Over here is x2, y2. Now realize this is not some super small country that where there were only 322,940 cell phone subscribers in 2007. Okay? This is actually a pretty large country because this says in thousands. So it's this many thousand. So really 322,940,000. Okay? Now, let's see. I'm now going to plug in y2 minus y1. That y2 I'm going to write without any commas. 322,940 minus y1. Again, I'm writing it without those commas. This is y2. This is y1. So over the 5 years' time, the number of subscribers increased from 273,229,000, which would really mean 273,229,000. By saying in thousands, that just saves writing out the zeros there. Okay? So this minus that over the 5 years. x2 minus x1. So that's a 5-year time span. Now let me pull up my calculator again, and here we go. 322,940 minus 273,229. That would be 49,711. So over the 5 years, it increased by this much. Dividing by 5, that's going to get us on the average. It's increasing at, right, 9,942.2 thousand. Okay? Now, if you don't like that number with the thousand, realize there should be 3 zeros after all of these numbers. That's what that means, in thousands. So just writing that rather than putting in on the 3 extra zeros. So we didn't want to write it with the thousand. Just multiply this by 1,000, which I'm doing, which is all just going to move that decimal point. So altogether, 9,942.2 thousand is 9,942,200. Okay? So the average rate of change during these years, from 2002 to 2007, the number of cell phone subscribers was increasing on the average by 9,942,200 subscribers. 9,942,200. Okay. Any questions there? This is just some applications of linear functions. And applications always mean some word problems and a little bit of data analysis also, looking at the charts and stuff. Hopefully it's clear why I'm writing this rather than just that. It would have to be a mighty small country if fewer than 10,000 people a year, the number of cell phone subscribers was increasing by fewer than 10,000 people a year. Okay, that's what it says, in thousand. Okay, so thank you for watching, and I will be talking to y'all soon. Bye-bye.